Good morning, students. So in previous class we are discussed about special properties of D block. So now other than the special properties, so in that one, so atomic radius, otherwise you take atomic volume. See, actually D block elements in what way we are studying? Left to right in the form of periods. So left to right in the form of periods. So already basic point we know. When we are moving left to right in the periodic table, what happens? Size, atomic size, so gradually decreases. So generally when we are moving left to right, the atomic size is decreases. Suppose if you see that one, so x-axis, y-axis, so here atomic radius. So on y-axis atomic radius, on x-axis atomic numbers. General, you are taken. See, next top to bottom also we know. Top to bottom what happens? So atomic size is increases. So top to bottom atomic size increases, left to right it is decreases. Suppose you take a 3D. So 3D radius is this one. So top to bottom 4D series. 4D series is more. 5D series is more. So 3D2 continuously it is decreases. See, suppose the scandium. So scativechroma, feconi, Kg. So up to copper it is decreases, slightly zinc is increases. So exponentially decreases up to copper. Next 4D series. 4D series what? Ezran, Motec, Yttrium, Ezran, Motec, Ruropod, Sicard. Up to silver it is decreases. Cadmium little bit increases. Next 5D series, Laftaure, so lanthanum, so Laftaure, Oipla, Ame, so Arum, gold it is decreases, mercury it is increases. Next, if you see the atomic size, here gap is more. So between 3D and 4D gap is more, means more size is increases. Next to 4D, 5D, very small. Gap is very small. So why it is happening? So lanthanum after you have 14 lanthanoids are coming. So because of lanthanoids, it has a lanthanoid contraction is observed. Lanthanoid contraction. So because of lanthanoid contraction, 4D, 5D is very close. So if you take the size, so compared to 3D, 4D size is very high. So little bit equal to 5D. So this is very important. Why this is happening? Size is very close to 5D means that is a lanthanoid contraction. So already in basic chemistry, in first year only, you can understood that one. Next, suppose if you take ionic radius. Ionic radius. So generally, what is oxidation state? General oxidation state, already we are completed. General oxidation state of D block is +2. So already we seen in previous class, general oxidation state is +2. Suppose M+2 ions you are taken. So that means so it is atomic radius. Next, atomic number, Z value. So here continuously it is coming down. So you take 3D series. 3D series scandium. Scandium +2 to zinc +2. It is continuously decreases. See here. Here what happens is scandium to copper exponentially decreases up to copper, little bit increases. So because of why it is increases means so zinc has 3d10 4s2 completely filled electrons. Completely filled electrons getting a relaxation. So electrons will be relaxed, relaxation will be happened. Because of completely filled, the size is little bit increases. But here Zn+2 ions is continuously straight line, it is decreases. See the difference. That too. See that the same atomic radius also, atomic volume also. First of all what? Left to right in the period atomic size is decreases. So that is decreases. Next, top to bottom in the group atomic size is increases. So 3d to 4d increases, 4d to 5d increases. But 3d 4d gap is large, but 4d 5d gap is small. Why this is a small size means compared to our expectation not much more increases because of the problem of lanthanoid contraction. So after lanthanum we have 14 lanthanoids are coming. Because of this contraction the problem is happened. So this is only atomic radius, this is ionic radius. So generally D block element oxidation state is +2. So M+2 ions you are taken means there is no variation, direct straight line only, it is decreases. Next. So density also set. Next, ionization potential. Second one. Ionization potential. So generally it is represented with the IP. Otherwise, ionization enthalpy. So ionization potential or ionization enthalpy. So our general concept is what? Left to right. So D block elements we are studying. So again same concept. D block elements we are studying left to right. So left to right in the form of periods. So when elements are moving left to right in period form, what happens? Atomic size is decreases. So atomic size is decreases. Atomic size decreases means strong attractions are there. So strong attractions between nucleus and outermost electrons. So when we are moving left to right, this attraction between nucleus and electrons increases. So that's why electron is not easily coming outside. So that's why IP values are increases. So IP values are increases, just that is a general observation. But really you come to in 3D series. In the 3D series you observed means So scandium to titanium, it is increases. So vanadium, so chromium, so manganese, iron, so like that. It is irregular. Irregular manner it is observed. See, because of what happens here, half-filled electronic configuration, half-filled and fully filled electronic configuration has more stability. So because of that, suppose manganese is there, it is readily loses electrons. So means our expectation they are not going to give, but a half-filled electronic configuration purpose they are readily giving. So that's why they are imbalanced manner you will get this. Next, third one, that important reduction potentials. See, these are the very important topic. So reduction potential values. See, first of all, we have reduction is there, oxidation is there. So basics I am explaining, just you concentrate oxidation. So what is the importance of this? One by one we will discuss. Reduction. So here, one point. Reduction means addition of hydrogen, otherwise removal of oxygen. Plus means addition, minus means removal, you remember. Addition of hydrogen or removal of oxygen you call it as reaction. So oxidation, exact opposite. Addition of oxygen, otherwise removal of hydrogen, you call it as oxidation. This is one concept. Next, in any step, oxidation state. So oxidation state decreases. So that is also called as a reduction. Next, oxidation state increases. That is called as oxidation. Next, so Liogar. See, loss of electrons. Loss of electrons is called as oxidation. Next, gain of electrons is called as a reaction. So mainly these two only important right now for us. So your organic chemistry, these two are the major important. So general, suppose you are taken zinc become as Zn plus 2 electrons. See, zinc oxidation state is 0, become as plus 2. So 0 to plus 2, oxidation state increases. So oxidation state increases means that is what? Oxidation process. Next, zinc is what? Become as Zn plus 2 means it loses 2 electrons. So that's why this is also called as loss of electrons. It is called as oxidation. Suppose the zinc become as Zn plus 2. That process you call it as oxidation. Next, reverse you take. Zn plus 2. Taken 2 electrons. It become as zinc. So plus 2 to become as 0. Plus 2 is become as 0. That means what? Plus 2 to 0, it is decreases. Oxidation state decreases. So oxidation state decreases means reduction. Next, Zn plus 2 is absorbing 2 electrons. So gain of electrons. Also you call it as reduction. So now you understood reduction. So what we are going to discuss about reduction potential values. Suppose whatever the atom or ion, so reduction values the scientists are given. So based on that values, say I am giving reduction potential series. So that is Likanamalji, Fekadko, Nitilehai, Coifacial, Mago, so mercury. Next to gold. Iodine after bromine, chlorine, fluorine, butane. So scientists are identified the reduction potential values and they are given one sequence. They are taken hydrogen reduction potential value is 0. So scientists are taken hydrogen is 0. Based on this hydrogen, this is called as a reference. Next, compared to hydrogen, how many readily loses electrons? Left one is a negative reduction potential values. So here reduction potential values are negative. After the hydrogen, reduction potential values are positive. See, left one has a highest reduction potential values. So left side elements have highest reduction potential values or high negative values. Next, right side one. So right side one has a lowest reduction potential. Lowest reduction potential values, these have positive values. Next, left one is readily loses electron. You take any two. Left one readily loses electrons. Right side one readily gains electrons. So this is one important point. Next, this is another important. So point to point you must perfect. First of all, we discussed what is the reduction, what is oxidation. So scientists only they are given one line. They only identified hydrogen, they are taken as a reference. That value they are provided 0. Left side of the hydrogen, they have negative reduction potential. They readily loses electrons. Next, after the hydrogen, they have positive reduction potentials. They are not readily loses electrons, they are readily taking electrons. So left one is loses electrons, right side one is readily taking electrons. Suppose you take lithium and potassium. Lithium is loses electron, potassium is taking electron. Suppose zinc and iron plus 2 you are taking. Zinc loses electrons, iron is taking electrons. So zinc and copper you take. Zinc loses electrons, copper is taking electrons. Zinc and hydrogen you take. Zinc loses electron, hydrogen taking electrons. Hydrogen, copper you take. Hydrogen loses electrons, copper is taking electrons. Say, for example, you take zinc and copper. zinc Cu plus 2. So zinc is there, copper is there. What happens? Left side is loses electrons. Zinc loses electrons. So that's why zinc become as Zn plus 2. So zinc loses electrons. Next, copper is taking electrons. So copper plus 2 is taking electrons. It become as a copper 0. So it is gains electrons. So loss of electron you called as oxidation, gain of electron you called as reduction process. So everything, reduction potential value. One more thing, highest negative reduction potential value, that ion is stable. So one more, highest negative reduction potential ion has more stability. So this is only very important. So for example, for this, so I am taking Zn plus 2 ion, copper plus 2 ion. In these two, which is more stable? Zinc plus 2, copper plus 2. Who will explain? This line only explains. Zinc has a negative reduction potential. Copper has a positive reduction potential. So zinc has a negative reduction potential. Copper plus 2 has a positive reduction potential. So highest negative reduction potential ion has a more stability. So that's why this is stable. This is unstable. Next, suppose you take both negatives. So zinc iron, Zn plus 2, iron plus 2. In these two, which is more stability? If we are asking. So zinc is left side, iron right side. Left side one is readily loses electrons. Readily loses electrons means that it become as ion. So stability is more. Left ion has more stability. Suppose you take lithium, zinc. So lithium is plus 1, zinc is plus 2. What is the stability? Which ion is more stable? So left side ion is more stable compared to right side. So lithium is more stable ion than zinc plus 2. So reduction potential is explaining which ion is more stable. So next. So the reduction potential value depending on where. So another important point. The reduction potential value is directly proportional to, otherwise you take inversely proportional to the sum of the ionization potential, sublimation energy or enthalpy plus hydration enthalpy. So reduction potential value is inversely proportional to the sum of ionization potential. So IP means ionization potential. Next, sublimation energy